Hello friends, my name is Mr. Dhawale, Department of Chemistry, RBNB College, Sri Rampur. In today's lecture, we are going to focus on transannular effect. Okay? In this section, first, we already learned or discussed regarding the larger ring system or rings other than 6 membered. Okay, in that case we have seen smaller ring system, medium sized ring system and larger ring systems. Okay, so the transannular effect is particularly shown or seen in medium sized rings. Okay, so why that such a type of effect is seen in only medium sized ring system? The answer is that medium sized rings behave as like larger ring system or also as like a smaller ring system, so that these are the boundary line rings. Okay, and in this case we see these are the special different properties which are only seen in the medium size rings. Okay, so this is one of the property, transannular effect. Transannular effect. Okay, so first we look transannular effect. Suppose we have a ring system. I show here, this is one of the, suppose this is one of the ring, okay, and having protons. Suppose here you see this is the ring and having some carbon atoms. I didn't show actual ring. Okay, so this is one of the framework of ring having protons, which some protons are present at the periphery and some protons are present in the inner side like this. Suppose these are the protons present in the ring or inner side of the ring, and some protons which are present outer side of the ring or at the periphery of the ring. Okay, and here we can divide these protons into two categories. First category is the inward protons and second category is the outward protons, or which are pointed outward. Okay, so that transannular effect is only concerned with the protons which are present in the ring or inner side of the ring. At that time you see here these protons are very close to each other, and this condition we seen in the medium size ring system. Okay, and in smaller ring system such a type of interactions are also possible, but that system is very rigid. Okay, so that there is no room for the single carbon-carbon single bond rotation, so that this effect is clearly seen in medium size ring system. Okay, so here you see these protons are very close to each other, and at that time it will give some interactions, and that interaction comes out into the chemical changes or chemical reaction into the compounds, and we get undesired product. Okay, instead of desired one. Okay, or with the desired product we get undesired product and different product due to the transannular effect. Okay, so simply you see the transannular effect means the effect which is shown by the atoms which are present in the ring, which are very close to each other, and it gives some physical interaction and it can convert into the chemical changes. So we call this is the transannular effect. Okay, and the strain occur in the medium size ring system, which is transannular strain, and that strain is totally concerned with the protons which are present in the inner part of the ring. So these are the hydrogens which are pointed inward, which shows only transannular strain. Okay, these proton shows transannular strain. Okay, these are inner protons and these are the outer protons, or the protons present on periphery. Okay, then we see the transannular effect with suitable example, and we have one example. Suppose we take here, this is the carbonyl group which is present in the ring system. Here this is CH2 group. Here I write M-1. Here also another CH2 group which is a part of ring, N-1. Then here we write nitrogen, and here we write methyl which is connected with this nitrogen, and such a type of amino ketone we have. This is cyclic structure, and here what is the meaning of this M and N? Okay, so this is M-1, CH2 M-1. Suppose the value of M is 5, then we write here CH2 5-1, and also N is equal to 5. At that time we call this is the CH2 5-1, and this is the size of ring. Okay, means what? 5 minus M-1 number of CH2 groups and N-1 number of CH2 groups, means 5 minus 1 means here we have 4 CH2, and here also we get 4 CH2. Why we minus 1? We write here -1 because we have two another atoms which are present or which are part of the ring system. So that we write here 1 minus means what? 1 for this carbonyl and another one for this nitrogen. So this, suppose we write here a ring size in this manner. M is equal to N is equal to 5, means what? This is the 10-membered ring system. How? So value of M is 5 and N is also 5. So 5 plus 5, 10-membered ring system. And what is the number of CH2 group in that system? So here M-1 means 5 minus 1, 4. 4 is this number of CH2 group, and also N is the 5, and here we write N-1, 4 number of CH2. So this total number of atoms present in this ring system, or what is the size of that ring, which is 10-membered. So in this case here we write 10-membered ring system. Okay, then so here you see this is the 10-membered. Okay, when we change the number of M and N, then the size of that ring will change. Suppose here we write M is equal to 5, N is equal to 4, then this is 9-membered ring system. When we write M is equal to 4, N is equal to 4, then this is 8-membered ring system. Okay, so size of ring system will change as we change the number of M and N. Okay, so what is the effect on the reaction condition or the product when we change the size, and which doesn't change the reaction condition for the this type of example? Suppose we carry out protonation. Okay, so now the simple way, when we see the larger ring system, in case of larger ring system, what type of reaction we have seen, okay, or what type of reaction you've seen in case of the open chain structures instead of this type of cyclic structure. Here we see, suppose this is our open chain structure, and having this one is nitrogen, and here methyl group, and here also carbonyl. Okay, at that time you see protonation is carried out like this. Lone pair present on the nitrogen will easily abstract the proton. Okay, why? Because that lone pairs are available for the donation. Why? Because nitrogen is somewhat less electronegative, and when we see such a type of reaction in case of cyclic ring system, as the ring size which can affect the desired product, which can affect the product. Okay, then here we see here also lone pairs are present on this nitrogen atom, and that nitrogen atom will abstract this proton. Okay, in normal condition, or in the simple way we write this type of product. And here your product contain M-1, here we write N-1, and we get here nitrogen, here one proton, and here CH3. Nitrogen carries positive charge, and this is your product, and that product is analyzed or characterized by the IR spectroscopy. And in IR spectroscopy you see here one value which is near about 710 or 715 or 1705 centimeter inverse, which is the symbol for the presence of carbonyl, either that is ketonic or aldehyde group, which is seen. This is one of the characterized value or characteristic value for the this type of carbonyl group. Okay, and that value is also seen in this product, and at that time you can say here this is one of the evidence for getting such type of product. In the product there is the value is also present, so that we have seen the reaction is occurred like this. Okay, the lone pair present on nitrogen atom will abstract the proton and get positive charge. Okay, but in another case, suppose we see protonation. Okay, so such a type of reaction is observed in what type of ring system? Okay, so this product or such type of product is observed in larger ring systems. Okay, and here we get another product. And here we have transannular bond. Okay, so here we see in this cyclic structure we can divide this cycle into the two different cycles, or which contain two common atoms present in this bicyclic system, and that bicyclic system we get by the formation of transannular bond. Okay, so the bond between nitrogen and carbon, which is transannular bond. Why we call this is transannular bond? Why? Because that bond formation is possible only the transannular interaction. Okay, so how such type of bonds are formed? Okay, so answer is that when the nitrogen lone pairs are attacked on the proton in the normal or ordinary conditions or in larger ring system, but in this case that lone pairs are not abstract the proton. Why? Because the lone pair and the carbonyl carbon, which is also electrophilic in nature, they are very close to each other. Means what? This carbonyl group and the lone pair of the nitrogen, which are very close to each other, at that time, instead of abstracting this proton by the nitrogen lone pair, which can easily attack on the carbonyl carbon, and the attack is somewhat like this. So lone pair first approach to the carbonyl carbon, and here the bond is formed between this nitrogen and carbonyl carbon, and here carbon reduction is occur, and the proton is abstract like this. Okay, so you get this type of alcohol, and when we characterize this molecule, at that time we don't get the value of carbonyl in IR. Okay, this type of value 1710 or 1710 centimeter inverse is not seen in this case. Why? Because the carbonyl stretching frequency is not observed, because of that carbonyl is reduced into the alcohol, so that here that frequency or that stretching frequency is not observed. Okay, at the end of this example, we see how we get these two products, or which type of ring systems are able to give this type of product due to the transannular effect. Okay, so here simply you see the larger ring system can shows this one. So what type of members or what ring size comes into the larger ring system group? Okay, so here we see generally we see here 10, 11 or 11, 12 and more than 12 member ring systems are included in the larger ring system, and which gives this type of product, which can show the carbonyl stretching frequency, and there is no transannular bond between this carbonyl carbon and nitrogen, and so that we can say here there are some long distance or large distance in between the carbonyl carbon and nitrogen, so that there is no formation of transannular bond. But in this case here, in medium sized ring system, 8-membered, 9-membered ring system, and also in 10-membered ring system, we have seen such a type of transannular bond. Why? Because the distance between this carbon and nitrogen is very short, and that's why lone pair are easily attacked on the carbonyl carbon instead of the hydrogen, so that we get here transannular bond, and we have such type of product, and this product is observed in 8-membered, 9-membered, 10-membered ring system, and here this type of product is observed 11-membered, 12-membered and even 10-membered ring are also shown, and so on. Okay, so this example can show the transannular effect, and this is not an ordinary effect which are shown by the all type of ring system. This effect is only shown by the medium size ring system, so this is one of the important property of the medium size ring system, and this is one of the example. Okay, thank you.